Hello and welcome to this episode of Microchips. In this episode we are looking at a Harvard CB radio that I purchased off eBay as spares repairs not working, and it had a listed fault. Here is the listing. And the radio looks like it powers on, but what is very strange is that the RX and TX lights are on. But when he said the TX is fine, but the RX doesn't receive. But immediately looking at the RX and TX lights, that's maybe the issue. But anyway, I got it for £20 plus £6 postage. And you say there, spares a repair. It's like the Amstrad 901. That's right. It transmits, but no receive. So anyway, let's open it up, take it out of the packaging, and see if it looks like what was on the listing. It did come very well packaged. I've already taken it out of the outer box. It's come nicely wrapped in bubble wrap, and there we have the Harvard Amstrad 901. A little bit dirty on the top, but nothing a good clean won't sort out. Case looks in fairly good condition. There you can see the model, a H646, made in Hong Kong. All the screws look intact and original, no drilled holes anywhere. All the knobs seem to have been off and just put back on randomly, so that's easily enough sorted. I mean, is this the indication that somebody's been fiddling inside it? So why would you take the outer control knobs off? But anyway, it's an easy fix to just line them back up. There, that makes me feel a lot better. Switches on the front work nicely. And let's have a look at the microphone and the power lead that was sent with it. Everything came very well packaged. And there, looks like we have an original Harvard microphone and a long power lead. At least that's not been cut to like 2 inches like you see some of them. And it's even got a fuse in it, not just a piece of tin foil. Okay, all looking good so far. Let's take the mounting bracket off. And inspect this radio a little closer. I will give it a proper clean later on. I'm just getting rid of some of the surface grime. You don't know where this has been, so. Okay, let's crack it open and have a look inside. They all look like original screws, which is good. They don't look like they've been opened, or they don't look like they've been unscrewed before, which is good. It would be nice if nobody had been fiddling inside this radio and we get a genuine fault to play with. and the case is very tight. Okay, I just had to get a little pry tool just to open it, because it is very, very tight. Now we have a first look at the circuit board. And the initial inspection doesn't look like it's been tampered with. There are a few suspect solder joints, but that could be factory. And let's have a look at the component side. This looks like one of the other cheaper boards that was manufactured to this specification. At least somebody hasn't taken that big resistor out of the back to give it 10 million watt output. But apart from that, looks complete, doesn't look messed with. Yes, I know I realigned the channel knobs before, but hey ho. So we'll get all the case off, we'll get the front off, and then we'll have a look at seeing what's actually wrong with this radio. All the screws are intact and complete, so it's a good sign. It is actually looking like nobody has actually tampered with this radio before. Okay, front doesn't look too bad. A little bit of a clean up. That should look okay for 40 years old. Okay, everything looks good on the front. Just your normal everyday LEDs, switches, channel display. So I've dug out my dummy load so I don't blow up any output transistors whilst we're testing this. Got my power SWR meter. And let's switch on and see what happens. And sure enough, it comes on. And the RX and TX lights are on. Channel display's on. And it does actually transmit. And it's transmitting 3.5 to 4 watts, which is well within specification. There's nothing wrong with that at all. Just verify my dummy load's working correctly, so I've not used it for a while. And yep, as to be expected, it's working fine. Yeah, RF output seems okay. Nothing's getting hot. So it is as described in the eBay listing. It does transmit. Now what about receive? Does it actually receive? Channel change works. Might have to get some switch cleaner into the channel changer rotary switch. I notice some of the segments are flickering when you change it. But let's try a transmission from my TRC 1001. And sure enough, no lights are lighting up for receive. And we can hear the transmission on my realistic handset. So transmit is most definitely working. So next, let's try my frequency counter, see what's happening with that. Try channel 1, 276016, yeah, it's okay. Channel 40, 991, yeah, it's fine. It's just 9912, yeah, it's a little high, but it's fine. Okay, that's good. So transmit is fully operational. Good RF output, near enough on frequency. We can hear modulation. So that's all good. Just placing my realistic handset nearby to it, you can hear a tiny bit of something, but it's hardly noticeable. So there definitely is some form of receive fault. I think the key to this fault is the RX and TX lights being on. So I think I'll look at the schematic diagram. So here we have the Amstrad 901 schematic, which was nicely reproduced by somebody, who I will do a close-up of that in a moment. So let's have a look for RX and TX switching, because if the RX and TX are both on, something bizarre must be happening. So we've got RX and TX, but we've got a TX inhibit on that, so that's fine. Got power supply area, which is internal in the radio. And we have RX and TX voltages. So maybe this is the good start, because we have R8 8.6, TX 8.6 being fed from switch 13.8 through a regulator to gain this 8.6 volts. And Q18 looks like that is the TX switch. So let's have a look for Q17 and Q18. See if those voltages are correct, and Q19 as well. So Amstrad service manual, all through, and we have a board layout, because with this being the cheaper board there's no silk screen, so this is the only way to find our components, and there's our Q18 and 19. So let's investigate those. So now we know where Q18 and Q19 are, let's try and get some voltage measurements. I'm not sure what's going on with that one. It's very hard to get the meter probe into there. So we'll keep on trying, see if we can get a reading. So we have 8 volts on one of those legs, 8.6. So that's what we were looking for. Well, we got the 8.6 on the input, but we shouldn't have voltage on the output or the collector of Q18. Let's check the PLL voltage. It's good. And we're just checking the RX and TX input to the PLL chip on pin 20 with the LC7137. That looks good. So the PLL thinks it's switching, which we know it's switching because it is actually transmitting, but there's no abnormal voltages around there. So the question is Q18 leaky? Do we have an issue there? Let's try and measure it in circuit. But very hard to do. Don't want to start bending these components over unnecessarily. I think the best way to test this is take it out and test it. So I've desoldered where I think it is, and there it is. There's our Q18. So let's see how that measures. See whether it's gone leaky or anything. To be honest, it'd have to really leak strangely to cause a problem, but that looks a normal diode junction. That looks a normal diode junction. Doesn't look like it's leaking to me. So as far as I can see, that transistor is working fine. So is it a bad capacitor somewhere? So let's put this transistor back in. We've got TX and RX voltage there that go into the LEDs on the front, so they are tied to the TX and RX voltages, and there's the documentation and the copyright for the nice schematic diagram that this fine gentleman's made. So with the RX and TX lights being on, there must be something wrong with the RX TX switching, which must be in this area. It's got to be around Q18, Q19. But then again, there is the Roger Bleep circuit as well. I'm just going to check a voltage on another capacitor, which is on the TX 8.6 line, which on the schematic shows it being right next to Q18, but in reality it's completely the other side of the board. I'm going to see what voltage there, because I'm suspecting bad capacitors. I don't know, my hand's covering it up, but we do have a... It's not 8.6 volts on there, but it's a very strange voltage that's bouncing all over the show. I'll try and get a better shot of it. So this is in RX state, but we're getting this 6 volts on the TX line, and when we transmit it does go to the correct voltage, but when we return to receive we are getting a voltage, and I believe this should not be there. So back to Q18 again. There's got to be something to do with this, because we have the same voltage, it's on the capacitor. We have the 8.6 on the input, which is fine, which is stable, but we get this weird fluctuating voltage on the output or the collector. Something just doesn't look right around here. I need to try something. So I've just desoldered Q18 once more, and we're going to try the radio with no Q18, so no TX voltage, and the transmit light has gone out and we are receiving. That is me transmitting from the other radio, so it's definitely to do with this TX voltage being on when it shouldn't be. So let's put Q18 into the transistor tester or component tester, just in case my meter's not reading it right, and it reads correct. So as far as I'm concerned, this is not the problem. Try the TX on the mic plug. And we do have a voltage, but I believe this should be pulled to ground on transmit, so you would expect something there. I don't think this is. So let's try some other things. So we measured 134, we know where that is, we've measured that. So let's try Q22, which looks like it could influence Q18, because it must influence Q18 because of the Roger Bleep circuit, because it must be able to hold the transmit on. I'm looking around for this Q22, and there we have it right at the front near the LED bar graph driver. So let's measure some voltages around there, see if this gives us any clue as to what's happening. Okay, to be sure, let's take it out and measure it, see if it's leaking, causing Q18 to switch on. Doesn't look like it's leaking to me. Both junctions look okay. So I don't think this is our issue. Again, I'm suspecting a capacitor, but I just can't see a capacitor that's connected to a voltage rail that could leak into the TX line. And when you have Q18 disconnected, it works fine, apart from there's no transmit, obviously. So let's have a look at some other components. So, is it D19 that's leaking on us, that's causing Q18 to come on? So let's find D19, and D19 is just below Q19. So let's get that out and have a look. And there's D19. And that's reading like any diode normally would. Doesn't seem to be leaking. Put it in a component tester. Not showing any errors on the component tester. Let's compare it against a new diode. And the reading's very similar. No reason to suspect this diode is at fault. So our problem is still there. So at this point I'm starting to think why is this happening? So I started to just blanket test components around the Roger Bleep circuit and the TX 8.6 volt circuit, to no avail. I pulled out D20, D21. I've also pulled out a couple of other diodes that was suggested on a document I found. D20 was actually mentioned for this fault, but that didn't make any difference. But I knew as soon as you took Q18 out of circuit, receive was restored. So this transistor had to be conducting some voltage, maybe not the whole TX 8.6 volts, but it was conducting some voltage. Why would it be conducting voltage? Because you remove Q22 and the problem's still there. So that only left one thing, D7. But that's PLL transmit, and I didn't suspect this at all. But this is the only diode that I've not tested around this place, and it's the only other thing that's connected to the base of Q18 that could have an influence on Q18. So let's find D7. So looking at the board view, there's D7 right next to our PLL chip. Okay, let's have a look and see what D7 is. So there's D7, and it's under a load of crud. And D7 has just broken apart. It has just disintegrated. So let's remove the remains of D7. Now I have seen this kind of glue before on high voltage components, that even though it was non-conductive when it was originally made, over the years the glue has broke down and turned conductive. I'm wondering if this is the case. This glue has turned conductive and done something to our diode, and there's the remains of the diode that's just fell out of the radio. I didn't put a lot of pressure on that diode when I touched it. It just literally just crumbled away. I mean, I did actually remove some of the other diodes in the radio without a problem. And you can see this gluey crud is all over these components. Why would you put this? Is that glue there just to hold that wire in place? Is that why they put it there? Because you wouldn't expect this component to get hot. It's not high voltage, it's just pulling a signal from the PLL chip. Got a quick look on the data sheet, find out what the actual diode is. It should be 1M4001, but I've only got 1M4148, which is fine. It will do. So let's fit a new diode and see if this actually cures our problem. I mean, I'm very high hope here, because nothing else that I've tried has even shown the slightest little bit of problem, little bit of fault anywhere. This is the first thing that I've spotted that has been not right. So let's power it on, put the power lead in, and see if we've actually cracked it. And we'll switch it on, and there's no transmit light. Oh, that is fantastic. No transmit light, that's brilliant. Let's try a receive with the other radio. Transmit's working fine, it's switching perfectly. Switch Roger bleep off. And let's try a transmit from the other radio.
Test, test, test. 1, 2, 3.
And there we have it. Let's just do some further tests, make sure everything's good. It's receiving off the other radio.
Test, 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 1, 2,
You can hear audio.
test, test, test. Test, 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 1, 2, 3, 4, 5.
Yep. Transmit works fine. Ah, the good old Roger bleep. Pop it back on high power. A close up of the SWR meter. Just below 4 watts. Let's do some other checks.
Test, test, test. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Receiver's working good now. Let's try some different channels. Try 40.
Test, test, test.
Yep, receives good.
Test, test, test. 1, 2, 3, 4, 5. 1, 2, 3,
Here.
1, 2, 3.
Receives good. Squelch works.
Test, 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 test.
So there we have it. It was just one diode that was causing our issue. One diode that was encased in some glue that had solidified and corroded over the years. And whether that glue was actually conducting, or whether it had broke the diode down and the diode was conducting. Either way, that was our issue. That was our problem. Just one little couple of pence diode. So now it's time to give the front a good clean. Some foam cleaner. Just being very careful on those edges, because I did actually hear one crack then. So what we'll do is we'll just quickly melt it with a soldering iron, just to try and hold it into place, because these are very brittle, especially after 40 years. I'll just be gentle with the soldering iron, just give them a little touch. Apart from that, a few other marks on the front, but it could be a lot worse. It actually cleans up quite well. A few marks on the bottom, but you don't see the bottom of the front. Now a window cover for the channel display dropped out as I was cleaning it, so that's a good excuse to give that a good clean. Pop it back into the front fascia. And we'll give all those control knobs a good cleaning as well. So I think this radio deserves a little bit of a clean now after all that stress it put me through. So they look all nice and clean now. So let's reassemble it all. Give the bottom cover the same amount of TLC, but foam cleaner with a brush, gets it in those slats. Wipe it back off again. Get rid of any dust from the inside. Another quick clean of the top. It's nice to see there's no extra drill holes in the top. Quick wipe in the inside as well. All looking nice. Let's reassemble it all now. A little bit fiddly to get all the switches and all the LEDs lined up just correctly. Don't want to bend any of those LEDs. And there we go. Let's gently put these screws back in. Not doing them up too tight as I don't want to damage the already brittle plastic. I think it's looking better already. Turn of all the control knobs in one direction. Just to make them all line up in exactly the same way. So volume, squelch, now the RF gain. And last, the channel change. Just slides on. Now let's resolder the speaker. and attach it to the radio. All goes into place nicely. Let's put the top cover back on. Place those screws back in. There we go, all the 4K screws back in. Now let's give the microphone a clean. So I use the same technique as before, a little bit of foam cleaner and a brush. Just brush it into all the places on the microphone. See if we can get rid of a bit of the grime that's on it. It's nice to have the original microphone that comes with it. Get a cloth, wipe it all off. Everything looks good there. It's even got a little grub screw that holds the connector in. Let's tighten up the cable restraint. And connect it once again to our radio. That's better. So one final test. Transmitter and receiver working correctly. That's me transmitting from the other radio, working nicely. Let's go to channel 40, and it's all good. So there we have it, a Harvard radio saved from the scrap pile with the cost of just a couple of pence component. I may have to revisit this radio to clean the channel change. I did notice that some of the segments were a little bit twitchy, and there's that famous bleep. So anyway, I hope you enjoyed this video of a diagnosis and repair of this vintage radio. As always, thank you for watching, and see you in the next episode.